Okay, so here we are solving systems of equations. This is actually out of a pre-cal book. The reason I'm mentioning that is because while the strategy is the same, this is not a, these are not two linear curves. We have this curve here, which is we're going to see in a minute is nonlinear, and then this one is linear. I think that they do intersect. What I would do, frankly, is I would go look at the curves on a graphing utility. The problem with this one is you're going to see in a minute is that there's an issue here. Okay, so remember when we say solve a system, what solving a system means is to find where the systems or find where the equations intersect. So we're going to do that. If you don't mind, I think I'm going to do this one by substitution. And what I'm going to do is, what I normally do here is I'll just name the equations. I'll name this one the first equation and this one the second equation. And that may or may not be necessary in this case, but it's a good way to keep track of stuff because it, I don't know, it gets kind of convoluted, I think. So I'm going to start just, what I think I'm going to do is I'm going to solve this one for x. So solve for x. When I say solve for x, my intention is to put what I get in here. So what we're going to do here is this. We're going to get, I think we can agree that x is equal to 6 minus y squared. Can't we? Yeah, let's try it that way and see where we end up. All right, I'm not sure what I'm going to do right now. All right, let's try that. So here's that x value. So I'm going to take the second equation. This is my revised equation number 1 because I'm going to plug this into my E2 equation. So I'm going to take this, it says x here, and x is 6 minus y squared, right? That's this x plus 2y is equal to 3. So I think that's what I'm going for here, and let me see what we're going to do with that. There's no reason I can't. So we have negative y squared plus 2y plus 6 equals 3. Let's move this over if you don't mind. Negative 3 here, and we get, yeah, take negative 3 from both sides, negative 3, and we get y squared plus 2y plus 3 is equal to 0. Never mind, I'm going to factor something out here. I don't quite know what I'm going to do with this mess yet. Just looking at it. I think if you don't mind, I'm going to multiply the whole thing by negative 1. That will give me y squared minus 2y minus 3 equals 0. So now, is this factorable? So can we factor this? We have y here, two numbers that multiply to negative 3 but add to negative 2 would be y minus 3, I think, and y plus 1. Doesn't that work? Y squared, y, negative 3y, negative 2. Yeah, that works, doesn't it? So that's really pretty. Is equal to 0, right? Now, one thing we have to be careful of is this. If you think about this from an Algebra 1 standpoint, this is kind of weird here, isn't it? Because here we have factored for y, not for x. Right? So we're getting ready to get solutions for, so we have, look, check me out, y equals 3, not x equals 3, because when we go back to plug in to find out, we have to figure out where we're going to plug this back into. And then we have y equals negative 1. That means we have, one of our points is the point something 3, and the other point is the point something negative 1. That's different than the way we did that in Algebra 1, right? Okay, so what are we going to do now? We're going to go back. We're going to go back and we're going to plug in if y equals 3, then what is x equal? So I think I'm going to go up here. Put it in here. So x plus 2 times, what do we say? Y is 3. And we get this, we get x plus 6 is equal to 3. X is equal to negative 3. And that's true. So we get the point, we get the possible point, right? Remember, this is the x value. I know that those years of algebra got that twisted, doesn't it? So if y is 3, then x would have been negative 3, right? So just take a look and let's finish this up, I guess. Let's take a look here. I'm going to do the same thing here, right? In this case, though, that's how we got our negative 3. So let's get rid of that mess. So we got that. We also have a possibility that y was equal to negative 1. Isn't that right? Y was equal to negative 1. So I'm going to go and do the same thing. I'm going to take one of the equations. This is the easiest one for me. I'm going to take out the x value. It's supposed to, right? X is supposed to be x plus 2y equals 3. So x plus, we said y was negative 1. So we get x minus 2 is equal to 3. Keep moving out here. We get x is equal to 5. X is equal to 5, not y. So we have this. If you want to know, it's 5. If you were wondering what this equation looks like, the equation looks like this, doesn't it? Here's the Cartesian plane. Here's the Cartesian plane right here. And our function, one of our functions looks like this, doesn't it? Goes like that. And like that. Right? And this is our x plus y squared equals 6 equation. And then we had this part of the equation that did this. That did this. And this is the part that is the x plus 2y equals 3. 2y equals 3. And we're going to say that they intersect here at the point 5, negative 1, and at the point here, negative 3, 3. So those are our solutions. It was not the easiest problem in the world, but very doable. And it's really cool if you look at this. Well, we're going to look at this. I'm going to do many more of these, but I'm going to do them on the precalculus so you can see what the other possibilities are for doing this. So nicely done. Good work. Keep studying. Keep practicing this. This is a skill worth having.